Hello, I am Kiera Bacon,
And I'm Sam Pollock.
and we are presenting the game 2005 Assignment 4, 3D Collision Detection and Response.
And as always, we'll start off showing the program in action. So we've got a start scene here introducing us, and when you press start, it loads up the main game scene. Here we've got the spheres and some cubes. You can collide off the cubes and send them going. The cubes can hit each other and push each other along. And then we have 3 different spheres for you to interact with here, each with a different size and different mass. So you can bounce off those. Get different ricochet responses based on the variables. And then on top of that, got a pause function, which lets you adjust some variables and return to the main menu. And now Kiera is going to start you off on a tour of the scripts that makes it go.
All right, so moving to the object pool for now. For this project, the player starts out with a pool of only 10 bullets. To achieve this functionality, we split the object pool into 2 parts. The pool itself, which has a queue of inactive objects, and a pool returner class, which, upon meeting its trigger, returns the objects to the pool. In this case, the trigger is a timer, which can be set in the player behavior, and which gets restarted each time a bullet is fired. Due to this system, theoretically, any object could be put into the pool. Next, let's move on to the collision manifold. So, in fact, this collision manifold works perfectly for sphere-sphere collisions, obtaining the penetration distance and point of contact between the spheres. For AABBs, it determines the axis of penetration by comparing each of the axes and finding which one has the least penetration. And then it uses that to determine what the collision normal will be. Now I'll pass it over to Sam to talk briefly about when the case of cubes and spheres together.
Okay, and in the case of cubes and spheres, it does a bit of a combination of the two to once again determine where the point of collision is, and as well as the penetration, and then adjusts accordingly.
Okay, so moving on to the collision response, the collision manager. In this case, all the collision response is handled in the collision manager class. For each collision which was detected, the manager generates a collision manifold. Then, if the penetration calculated within is greater than 0, which it should always be, it uses the velocity, penetration, and normal to calculate the penetration response and collision impulse using the formulas we discussed in class. It also uses a bounciness factor, which is the minimum of the 2 bouncinesses on each of the colliding objects, and then a friction factor, which is the square root of the 2 frictions multiplied together. Objects with the physics behavior class also have a mobile Boolean, which, if unchecked, prevents that object from having its own collision or velocity modified by the manager. So now I'll pass it on to Sam to talk about the other functionality.
Okay, I'll close this off with a quick look at some of the HUD and UI and how that works. So the set values that you can access in the pause screen simply pulls from the relevant object's physics behavior script and allows you to adjust those values. And in the pause scene, the pause menu, it re-enables the mouse control and stops the game timescale so that the simulation doesn't continue during the pause. And that's what we have. Anything else we want to get into, Kiera?
Nope, thank you very much.
Okay, thanks for watching.